Subscribe the channel and press the bell icon for more interesting videos. Hello friends, my name is Dr. Bhupendra Sen and today I am going to discuss on Fourier transform infrared spectroscopy, that is FTIR. FTIR is an instrumental technique in which we obtain IR spectrum in IR spectroscopy. What is IR spectroscopy? What is its basic principle? How we interpret spectrum? How the compounds are identified are illustrated in infrared spectroscopy section. Today in this video we will see what are the main component of FTIR, how the FTIR works and how the spectrum is obtained. This is the block diagram of FTIR and you can see the main components of FTIR are source, interferometer, sample and detector. Let's see one by one each of the component that what it does in FTIR. First one is source. It generates IR radiation. This may be different type as per the requirement of instrument. Here are some source are listed. Second is Michelson interferometer. This is basically a set and arrangement of beam splitter, moving mirror and stationary mirror. It is also called Michelson interferometer. It is a very important component of an FTIR instrument. Next is sample. Any sample, either it is solid, liquid or gas, all can be analyzed through FTIR. Next is detector. It detects the transmitted light and reveals that how much light is absorbed by sample. There are many types of detector which can be used in FTIR, which is shown in this slide. Let's see how the FTIR works and how we get IR spectrum. When IR radiation produces from IR source and reach at beam splitter, as its name implies beam splitter, it splits the beam into two beams of equal intensities. Out of these two, one goes to stationary mirror and second goes to moving mirror. Then this beam again reflects from both the mirror and combines at beam splitter. Here we should know some important terms. These are zero path difference, constructive interference, destructive interference and optical path difference. First one, zero path difference. Zero path difference means the distance between stationary mirror and moving mirror is same. At this point, light travel equal distance in both the direction and there is no path difference. And when beam combines at beam splitter, this is called constructive interference. Let's see what it's mean of constructive interference. Since we are talking about light and we know light travels like wave. Suppose light goes to stationary mirror is like this wave and the light goes to moving mirror is like this wave. At zero path difference, when both wave combines at beam splitter, since both have traveled same path, hence the height and valley of both wave combines and produce a high amplitude wave like this, and this is called constructive interference. This wave have higher intensity. Now what is optical path difference and destructive interference? Since moving mirror can move and it is not at the zero path difference. In this case, light travel extra distance. In this case, wave at stationary mirror remains same, but the wave goes to moving mirror has traveled extra distance. Now, there is a travel path difference in both the wave. This is called optical path difference. And when there is optical path difference, it is called destructive interference. Means wave goes to moving mirror, travel extra distance. In this case, when beam combines at beam splitter, then the wave cancel each other. This type of wave have lower intensity. These process are continuous and the wave came out from interferometer have different intensity. Means it has higher as well as lower intensity which continuously fall into the sample, and the wave match with the vibrational frequency of the molecule present in the sample are absorbed by sample, and the wave which are not absorbed by the sample transmitted and detected through detector. This produces spectrum which is called interferogram, which shows the relationship between energy and time. Then A mathematical calculation called Fourier transform is applied to this interferogram, which converts the interferogram into a spectrum showing relationship between frequency and intensity or absorbance, which is very easy to interpret. By interpreting this spectrum, we can identify that which molecule is present in the sample, what is its identity, and what may be its structure. Why should we use FTIR? We use FTIR because it is non-destructive, have good precision, and does not need any external calibration, and it is mechanically very simple. The information we found from FTIR, by which we can identify unknown material, quality of a sample, and the amount of component present in a mixture. These are the some important field where FTIR is used for the identification, quantification of various sample. Thank you for watching video.